Technology presents educational satellite television programs.
Hello, teacher. Hello, students. Welcome to our second lesson on van der Waals forces. In our previous lesson, we learned that dipole-dipole forces and London dispersion forces are collectively known as van der Waals forces. We learned that dipole-dipole forces are strong intermolecular forces between polar molecules. We also learned that dipoles are created by equal but opposite charges that are separated by a short distance. We discussed the strength of dipole forces and learned that in comparison to ionic and covalent bonds, they are relatively weak. Dipole-dipole forces have a strength that ranges from 5 to 20 kilojoules per mole. In today's lesson, we will learn more about London dispersion forces. We will look at an example of molecules in which this type of force is important. We will also compare and contrast the intermolecular forces that we have studied, including hydrogen bonding, dipole-dipole forces, and dispersion forces. All molecules exert forces on each other, even those that lack dipole moments. We know that this is true because every substance, including noble gases, change from the liquid to the solid state under different conditions. London dispersion forces act between all atoms and molecules. In fact, they are the only forces that exist between noble gas atoms and non-polar molecules. This is reflected in the relatively low boiling points of noble gases and non-polar molecules. Dispersion forces occur as a result of temporary redistribution of the electrons, which causes induced dipole-dipole interactions. As the number of electrons in the interacting atoms or molecules increases, the strength of the dispersion forces increases. Thus, dispersion forces increase along with atomic number, or molar mass. If we compare these noble gases, we can easily see this trend occurring. Students, as you look down this column of noble gases, what do you note about their boiling points? Please explain this trend.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. Thank you for your participation with that activity. How did you do? If you look down the column of noble gases, you can see that the boiling point of each element increases. This trend occurs because moving down the column, the induced dipole-dipole interaction increases. If you correctly answered that, you are doing very well. Let us continue this lesson by comparing and contrasting all of the intermolecular forces that we have learned about. Students, as you know, dipole-dipole and London dispersion forces are both part of a force that is the sum of the attractive or repulsive forces between molecules. As we learned in our last lesson, this excludes forces between molecules that are due to covalent bonds. It also excludes forces between molecules that result from the electrostatic interaction of ions with one another or with neutral molecules. Dipole-dipole forces are attractive forces that exist between molecules possessing dipole moment. London dispersion forces are attractive forces that occur as a direct result of temporary dipoles that are induced in atoms or molecules. At temperatures that are very low and at atomic speeds that are quite reduced, dispersion forces are strong enough to hold atoms together. This causes the gas to condense. The attraction that exists between nonpolar molecules can be explained in the same way. They are the only forces that exist between noble gas atoms and nonpolar molecules. I am sure you recall that hydrogen bonds are a particular type of intermolecular force that occurs when a hydrogen atom is bonded to highly electronegative elements such as fluorine, oxygen, and nitrogen. Students, let us do an activity. What type of intermolecular attraction would you expect to be dominant between the molecules of the following substances? Choose amongst hydrogen bonds, dipole-dipole forces, and London dispersion forces. You may begin now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I wonder what type of intermolecular attraction you assigned to the molecules of each substance. Before we go through the answers, do you know which of these intermolecular attractions is the strongest and which is the weakest? Hydrogen bonds are the strongest, then dipole-dipole forces, and then London forces. Covalent bonds are stronger than all of these. Hydrogen bonds would be the dominant between the molecules of ammonia and water. Dipole-dipole forces would be dominant between the molecules of the substance hydrogen chloride. Finally, London forces, the weakest type of force, would be dominant between the molecules of boron trifluoride and ethane. Did you get the same answers that I did? If you did, then you are correct. In today's lesson, we learned about London dispersion forces. Along with dipole-dipole forces, these forces comprise van der Waals force. We learned that London dispersion forces act between all atoms and molecules. They are the only force that act between noble gases and non-polar molecules. We also learned that dispersion forces increase along with atomic number, or molar mass. We compared London dispersion forces to dipole-dipole forces and hydrogen bonds. We learned that hydrogen bonds are the strongest of the three. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.